Hello and welcome back to another ASMS design series video, where today I'm going to be showing you prototyping the circuit for our sensor package used to measure parameters in supercell thunderstorms. So let's get right on into it. Alright, so since the last time you've probably seen this, there's a lot more going on. In the last video we were individually working with each of the sensors, like the GPS module here and our atmospheric sensor down here, and just working with them individually to make sure that they're reading back correct values and that the microcontroller was communicating with them properly. Now we're integrating them all together into the system, hence why we have the much larger breakout board. The one thing we don't have in this system right now is the transceiver radio, which is what is going to allow the broadcasting to our other sensor at our home base to get back values while this thing is deployed. So, the one new sensor that I haven't really talked about is this one right here, which is our IMU. And then there's also, this is not really a sensor, but this is our micro SD card board, which will write the values that these different boards gather onto this, so we have an onboard data storage. I know there's a lot of wires here, but it's not that confusing once I break it down for you. So we have our 5 volt and ground, which are running to these two power rails here. So these are powered down the entire vertical here. And then each of the breakout boards have a jumper wire connecting them up to the 5 volt and ground, so they are supplied with power. Then we have communication lines, basically, that are running between each of the boards that send the data, the serial data, to the Arduino Mega to be processed. So our atmospheric sensor and our IMU sensor, those use an I2C protocol, which means they have two communication lines. As you can see, they're these two right here, and then these two are what connect to the Arduino Mega, this SDA and SLC. So those are the connections where they go to in order to make that serial connection with our Arduino Mega. Up on our GPS, we have the transmit and receive pin, which have their own dedicated pins over here. And then the micro SD card is using SPI communication, which requires 4 leads. So that one, since it's the only board here, we can just directly wire it into our Arduino Mega. Alright, so here we are looking at the code that is going to be going on our Arduino. So in Arduino terms, the code that runs on it is called a sketch. So if I refer to it as a sketch or a code, it's the same thing. Looking at our code lines here, what we're basically doing is loading in some libraries. So these are just a set of commands and different things that are used within the Arduino in the sketch itself as well, to basically process and give us commands that we can use to operate the sensors. Then we have some definitions for different characters and float variables and serial pins that we're using in our on our Arduino. And then we have our setup, which basically is the first thing that the Arduino does when it powers on. So right now what it's doing is it's starting our serial line and then turning on all of the sensors and getting them to power up and get loaded. Then we have a void loop, which basically is what is going to recur every single time once it gets to the end of said loop. In our case, it's going to be gathering a set of data, storing them, transmitting them, and then repeating. So here we are. It's going to do a reading of the GPS, which is a function that we define later in the code. It is going to convert the values that it gathers. Then it's going to gather our atmospheric values and then our IMU values, and then store them into what we're calling a data string, and then it's going to log it to our SD card. Right now, like I've said previously, we don't have the transceiver on board yet, and that is what's going to transmit the data to us when this thing would be airborne. So outside of the loop, we have a function that basically works with the GPS in order to gather the GPS data, and then there's a clear GPS function down here, which gets rid of the old data so new data can come in. So that's a basic overview of what's happening in the code. So ultimately, in the end, the GPS, the IMU, the atmospheric sensor are all gathering values. They're being converted in the Arduino and then being stored on board, as well as eventually being transmitted. And it's not that complicated at the end of the day, but there's just a lot of different commands and protocols being used with each of the sensors, so it's important to have them all fleshed out. So now let's give a demonstration. Alright, so we now have our Arduino hooked up to the laptop, and what we're going to do is get the serial port running so we can show you basically what's going on and what the Arduino is going to read back to us. So if we open our serial monitor and give it a second to establish its connection, it's going to start reading us a string of values. So if we look and we read left or right here, we're not going to turn off auto scroll. So it is giving us our real clock time. This right here, these three values would be our latitude, longitude, and altitude. Right now, because we are inside, the GPS is not getting a fix to any satellites, so that's why it's not returning any of those values. We have our barometric pressure in millibars. We have our, I believe that is temperature in degrees Celsius. And then we have our humidity percentage. And then we have all of these values over here, which are acceleration values. So if we turn on auto scroll and I start moving around the board, they're going to start fluctuating and changing, as you can see. And that's pretty much that. So we have a constant data stream coming in with values from our board. The next step and the next video is going to be integrating our LoRa transceiver module into the mix and then getting this to transmit data via radio connection rather than just storing it on board. Thank you for watching, and I'll see you in the next one.